class is going to A. That's what that means. It is not correct. The chemical engineering sense has to be there. We have done already. And thing is that you can argue with me, but make sure that you are arguing. I have not penalized anybody who have wasted so much of my time. I have seen some of the cases, genuine valid reasons are there, but some of the cases we assume the answer is correct. This is not fair. Although I didn't penalize, but I will penalize. This is not correct. You should not be cheating at the end. That's what my point is. Okay. So, thing is that I have included the modified marks. We can look into it and we'll see what we are considering, and then we'll proceed further. So, we have seen the problems at 6 that we will be discussing slowly. Have you done the Graham-Schmidt orthonormalization of the function 1x x square, and how do they look like? Do you see that? How the functions look like? Have you plotted it? What is this function? I don't even understand this function. This is what? This is 1, right? That's what we should actually write by pencil when you submit to me, otherwise I don't know what to do. And also you plot 1x x square, so that will make sense. Okay, we have done I have given the statement of the Cauchy-Schwarz inequality, and we can prove the Cauchy-Schwarz inequality based on the technique what we actually discussed in the class for the Cauchy-Schwarz inequality. Okay, so I think by and large we have discussed all the properties of the functional space, and the only thing is remaining what actually we don't do in the functional space, that is called completeness criteria. So two things actually we are going to discuss before getting into the new topic of the functional space. That is called completeness criteria. Okay, and what we talk about is something called Cauchy sequence and something called completeness. Okay. So this is very, very important for the functional space. We talk about the Cauchy sequence and the completeness. What actually we talk about? Say for example, you have a sequence is 1 plus 1 by n. That means we generate the, we call it the Sn, is number of nth term. We have done sequence, I think, we take first level mathematics. So what is the first term? N equals to 1. First term is n equals to 1. 1 plus 1, 2. Second term will be 1 plus half, 1.5. And the n getting to infinity is coming 1. Right? So it is decreasing the series. Okay? So that means this is called as convergence series. This is called as convergence. Sometimes what can happen if it is 1 plus n, at n getting to infinity, the series also going to infinity, it is not convergent. So like that, there is something called convergence series and divergence series. Okay? And this and when we talk about the series, of course sequence series actually we have seen earlier. So when a series or sequence converges at the nth term, that is called the Cauchy sequence. So please look into the Google or some of the books of the Cauchy sequence. I don't want to discuss much here. And what I would like to talk about the completeness, which is important for the numerical analysis. So when we talk about numerical analysis, this completeness criteria is very, very important. For example, if you want to solve equation for a Newton-Raphson method, x square minus 4x plus 1 equals to 0. This has got an identical solution. You can solve by numerical this equation. And you can, best way to solve, we can write this as x equals to 4 minus 1 by x. Okay. X equals to, you can, what you can write x square equals to 4 x minus 1. Then divide by x, you get 4 minus 1 by x. Okay. So there is something called if you something called Picker's method. I will discuss everything when I do numerical or successive substitution method. Successive substitution method. What we do that, if you can write a function like x equals to fx, the numerical scheme, the way we actually see the solution is f of xn. Xn plus 1 equals to f of xn. So that is the way I think you might have done in the numerical earlier. Have you done it? How to do iteration method? Iteration actually goes like this. This is the y equals to x star, and this is the function. So this is the point the solution is. So you go this way and finally you get convergence. This kind of thing you might have done in numerical. So if you don't know this, that is fine. For example, you don't know anything. What I am saying that I want to solve this by using this. What I do that I will say xn. I want to have an algorithm 4 minus 1 by x. That means xn is the old guess. I can start with 1. What is my new guess? x1 is 1. x2 equals to 4 minus 1, 3. Right? x3 equals to 4 minus 1 by 3. How much is coming? 3 point something, right? If you have a calculator, you can just work with me. So you can write x2 equals to 4 minus 1 by 3. It is 11 by 3. x4 equals to how much? x4 equals, just give me this like this. It is better. No need. Huh? You give me like this. 11 by 3. Then 41 by. Next is x4 equals to, what is that? I want the rational numbers. Don't complain. You have to just put it here. 41 by? Yes, I want the rational numbers. x5, rational number. Rational number means if any quantity can be expressed, the ratio of the two numbers, two integers, these are called as rational numbers. How much? 153 by 40. So this is the way this number goes. So basically, if you look at, you got a sequence which is 1, 3, 11 by 3, 41 by 11, and 153 by 40. At infinity, you should get the solution, right? With this technique. What is the solution for this? Analytical solution, which is x equals to minus b plus minus b square minus 4ac, 4 square minus 4 by 2, which is 4 plus minus 36 minus 4 is 32 by 2, which is 4 8 is how much it is coming? 2 plus 3, right? So now if you look at, this is a series of the rational numbers, but the infinity, it is going to irrational number. This is irrational number. Root 3 is not rational number, it is irrational number. Root 3 cannot express the ratio of the two integers. It cannot express. Okay? So, these numbers, so if you look at the guesses, subsequent guesses, they belong to the space of rational number. But at the infinity of this number in this series, it will lead to the final solution, which is the irrational number, and that's what. So, set of rational numbers may not be complete. Completeness means at the infinity, if the number belongs to the same space, so this is the space of the rational numbers. At the infinity, it is going to the solution because iteration I am doing. At the infinity, it has to converge. When it will converge, it will go to the irrational number, which is 2 plus root 3. So, set of rational numbers may not be complete. I can conclude. Set of rational numbers may not be complete. It will become incomplete. It is incomplete because at infinity, that means in infinity, it will lead to a solution, final solution. You can go back home and check it out. Okay? Of course, numerically, you can see that they are actually rational number, but at the infinity, at the minute solution, if you look at the minute details, the solution will be irrational number. In that case, we cannot say this is a complete set. So these are the things actually, the small things you have to know. So let us move on the solution. So we have learned everything. So remember that when you did Ax equals to B, this type of things we have looked at the property of A, property of vector space. Of course, property of A was very crucial. Matrix property. We have seen so many things. We have seen how to find determinant and all. Here, our situation is A equals to F. Okay, and A is a differential operator. So what actually? So what we can actually do du by dx square equals to one of the simple situation du by dx equals to f. So what du equals to f, if you look at, it could be any kind of thing. It could be x square du by dx square plus x du dx plus u equals to some function of x. This type of thing could be there. This also equals to f. So this, when you have this kind of system, this entire set is known as differential equation. This entire set is known as differential equation. This entire set is known as differential equation. So in that case, it is quite complicated because Ax equals to B. If you look at A matrix was constant, B is a constant vector, you could solve it easily. Okay, so this solution of these guys is straightforward. Okay, you can even use eigenvalue, eigenvector, all those things we have seen without solving how to solve it. All those techniques will be applied. But before that, how to solve a simple differential equation, how to solve a differential equation is very, very important. Because differential equation could be very, very complicated. In that case, you may not get analytical or closed form solution. In that case, you may not get analytical or closed form solution. So, it is Ax equals to B. You know Cramer's rule or any such rules. If you have seen the numerical techniques, straightforward. But here, there is a whole lot of family on this aspect. So let us look at differential equations, different processes, and we will proceed step by step how to solve differential equation. So now you can see how any equals to get really complicated for the differential system, and we will be looking at different methods of the solution. So we'll start from the very simple. So LU equals to F means I will also talk about dy dx equals to F also, F or F of x. First order differential equation also I would like to know, because the first order differential equation has application in chemical engineering. Many blood tests can have dy dt. Okay, some variable is changing with time. Okay, in that case, for the first order system, how to solve it, and this type of applications actually they are also in control and some other areas in chemical engineering. So first kind of differential equation is dy dx equals to gx and x. This is very simple kind of differential equation, because if you write fy dy and gx dx, you integrate, you can get the solution. So what you can write, fy dy equals to gx dx, and next you integrate, you find the solution. And one of the example problem I will give you, you can go back home and try to do that. Dy dx e to the power 3x minus 2y plus x square e to the power minus 2y. How to solve it? By using this. Go back home, try to do it. So apply this, solve this, and solve and get the analytical solution. Okay. Next is, first technique is over. So when you have differential equation of first order, I am just talking differential of first order. When you have differential of first order, you have to see what are the techniques what you know, and you can adopt the technique. So this technique is known as separation of variables. separation of variables. Next technique we talk about homogeneous form. What this technique is? dy dx. You can have f of xy divided by g of x. Okay. And what is the how to solve it? Any idea? Y equals to bx. Y equals to bx, you substitute. Okay. So I will give you the example problem. Go back home, do it. 2xy dy dx x square minus y square. How to solve it? These are the what I am teaching now. This has been already done in BTech level or class 2. I think this part you know quite well. So I'll move to the next approach. Linear equations of the form. Linear equations of the form which is dy dx plus pxy equals to qx. We have discussed enough of this technique. Okay? And I'll give you the example problem. Example is which you can go back and do it. X plus 1 dy dx minus y e to the power x x plus 1 whole square. X plus 1 dy dx minus y equals to the power x into x plus 1 whole square. Next is slight extension of this technique. Okay. Slight extension of this technique is dy dx plus px into y qx y to the power n. How to solve it? So what you have to do that is y to the power minus n dy dx plus px y to the power 1 minus n equals to qx. And what to substitute? What is this technique called? Bernoulli's method. Okay. So these things you know. Next is, so you can pick up this example problem. So we'll come back on those techniques. Next is exact differential equation. Next is exact differential equation, which is mxy dx plus nxy dy equals to 0. And if dou n dou y equals to dou n dou x. Why it is like this? Can I explain from thermodynamics? It has been done in thermodynamics. It has been done in thermodynamics. We have seen in thermodynamics u of xy equals to c. So du equals to 0, which is dou u by dou x dx, dou u dou y dy. Generally, you can write dou u dou z as dou x dou z, dou y dou z. It is y, it is x, called chain rule of differentiation. It has been done many applications in thermodynamics. Okay. So this is the thing directly applied in thermodynamics. Okay. This differential equation. So if you have differential equation in this form, and if this is valid, then you know how to solve it. Pardon? So you know how to solve it, right? So let us take an example. dy dx y cos x plus sin y plus x divided by sin x plus x cos y plus y equals to 0. If you put y equals to vx, it will not work. Sometimes you have a tendency to reduce like this. If you look at, it is exactly similar kind of thing, right? And you get confused. You try to put y equals to vx, it will not work here, right? Y equals to vx will not work here. So in that case, we will say it is not possible to solve. Of course, possible to solve by exact differential equation method. What you do that? To write this as, this is m and this is your m. Okay? So it is n dy plus n dx. Sorry, this could be n and this could be m. I want to make sure be consistent with our skill. So these are n, these are m. Okay? So m is what? Y cos x plus sin y. So what is the condition? Dou m dou y should be or must be dou n dou x. Is it happening? Check it. Is it happening? Dou m by dou y equals dou n by dou x. Are you getting it? Are you getting it? Yes or no? Yes, 2 years are there, so I can actually assume that you have understood. So if dou m by dou y equals only dou n by dou x, you have to identify the function u. So this implies, so now you can see different perspective of thermodynamics also, how we are applying the things. So this m xy dx, n xy dy, it implies dv equals to 0. It implies dv equals to 0, right? And if d equals to 0, we can write u equals to some functions, some constant, okay? Or then, if d equals to 0, what actually is happening here? What is actually happening? So, what we can write m and n as in terms of u? M equals to dou u by dou x, n equals to dou u by dou y, which is equals to, m is given, right, y cos x plus sin y plus x. So now you don't need this one, only one will be fine. So du equals to integral y cos x plus sin y plus x dx plus what will be? What will be what? Integration constant will be what? Plus, it will be c or something else? Plus c or something else? Yes, excellent. Okay? So it plus c. Or you can just say gy, you can incorporate your even constant term, you can incorporate here. So what you can do, y cos x, so remember that for this case, y is constant, right? For this case, y is constant. So what is your solution then? What's your solution? Equals. du equals to y cos x dx means so much? Minus sin x, am I correct? Plus sin y into x plus x square by 2 gy. Now u equals to, oh sorry, this is already u. Okay, that's it. What's the solution then? Okay, so this you can actually work on that. Next I'll be going for the linear differential equations. So exact differential equation, you practice this kind of problem more from the Greval's book. You take the book B.S. Greval. I don't want to repeat all those things. Or you can look at the book by Kresnik. And you seen that book Kresnik? Okay. Resting and Deval has lot of applications on that. Practice. More problems you practice, much better, because exam also I will give 1 or 2 problems on this one. Next is linear differential equations. Next is linear. What is the number? Should be 5 or 6. Linear differential equations. Ax dny by dx to the power n, an minus 1x dn minus 1y dx to the power n minus 1, a0x y equals to dx. If bx equals to 0 is the homogeneous equation. If bx is not 0, it is non-homogeneous equation, and you know what is the solution. Okay, so you can have the complementary solution and particular integral. So if it is bx is non-zero, you will get particular integral. If bx is 0, we have only complementary solution. So for the homogeneous system, so bx equals to 0. Okay, and you get complementary solution. For the complementary solution, what we do for this case? How to find a complementary solution? You have to get the trial solution, right? So what we do, we try to write the trial solution. Trial solution is what? Trial solution y equals to what? We have done everything, boss. Why are you wasting so much of time? We have done. Vasudha, what is the trial solution for this? Trial solution I'm asking. You don't even, that's the problem is you guys don't even derive. You just try to see the final problem. So solution, yes. Amit. E to the power mx. E to the power mx, yes. Trial solution is equal to mx. What you do then? And so what I am trying to first do, I will talk about this a minus 1, a0 all are constant. Assume a minus 1 are constants. So if you put here, then these will be all constants. This is like some number, 2, 3, 4 some numbers. So what will you get in that case? You will get what? If you put the image, that's why you never derive all those things. You got the final solution, that's the problem. And GATE exam will not ask to derivation. That's another problem. Okay? A, what is that? N? E to the power mx, so it will be how much? M to the power? E to the power? A minus 1? A to the power? 1? Then it will go like this. Last term will be A0 e to the power mx equals to 0. Now you see that everywhere e to the mx is there. So e to the power mx is actually non-zero. That means if you take the other things common in a bracket, what will you get? You will get an m to the power n plus an minus 1 m to the power n minus 1 plus a0 equals to 0. This is a polynomial. This is a polynomial. And this polynomial we can factorize. This is school level mathematics. And you can get various roots. Okay? You get the roots, for example, m1, m2, and say mn. I am assuming the roots are distinct and they are not complex, they are not having any kind of similarity. They are all distinct, having distinct roots. Okay. And what is your solution then? So solution is phi 1 solution is e to the power m1x. Phi 2x is e to the power m2x. Like that you have phi nx e to the power nx. Because I said my trial solution is equal to mx. Roots are m1, m2, mn, right? So each of these will satisfy this differential equation. So that means they can be considered as solution basis. That means each are the independent solutions and they can form the basis for the solution. And we know that any vector, any function can be expressed a linear combination of basis function. And since each of them satisfy the solution, okay, they can form the basis of the solution. Okay, so my final solution is a linear combination of basis function. And what's a linear combination? Which is summation alpha I phi I x, which is my y final solution, I equals to 1 to n, and that's why we write alpha 1 e to the power n1x, alpha 2 e to the power n2x, and so on. This type of things are not there in the books. Since we know basis function, appreciate now why they are all combined. You just knew how to apply the formula. You should appreciate how it is combined. This is the way to appreciate. Since now you know vector space, you know functional space, and that is the way it goes. Right? So each of these are the solutions. The question is, I am now saying they are independent solutions. How can you prove the independent solutions? How can you prove the independent solutions? I am saying, okay, each one is satisfying. Doesn't mean they are independent. We are satisfying fine. If they are not independent, you cannot write it. What my assumption here is, they are independent solutions. How can you say they are independent solutions? How can you say that they are independent solutions? Let's see, who can give me the answer? Pardon? How to find all alphas are 0? Which matrix? How to find all alphas are 0? Which matrix? How to find alphas are 0? These parts are not in your. So what I am teaching now here, this was not in your telegraph or velocity. You will assume. This is the way it can be done. You will assume you got the solution. Your job was to get solution. How it is coming out, you don't care. I care here in the class. My question is very simple. How do you find the solution is independent? Otherwise you cannot add it. And if they are not independent, all the books will be wrong. What you suggested. How can you add it? Yes. What basis? This will be very complicated then. If I give set of functions and I ask them to verify they are independent or not, how to verify? What matrix? I don't care, I don't understand what you are talking, what matrix, how do you form the matrix? I don't see any matrix, I see only functions. What matrix? What matrix? Pardon? Wronskian matrix. See, even to get Wronskian matrix I have to struggle so much. Last class only I taught. So we have to talk about the Wronskian matrix. So let us have the formal way of analyzing this. So what we can actually talk about, if we have say d2y by dx square, say a1 dy dx plus a0 equals to say 0. This is the kind of common differential equation one can think about. We can also have a1 dy dx plus a0 equals to 0. And we can also have the trial solution. So what I am saying there, doesn't matter what is the power here, a square, cube, 8, even 1 also. Solution is valid, y equals to mx. This also will be valid. What will happen here? It will be a1 e to the power mx plus should be a0 by a0 e to the power mx equals to 0. So it is a1 m plus a0 equals to 0 and m equals to minus a0 by a1. And what's the, how many roots we are getting? Only one root. So your solution is y equals to say c e to the power minus a0 by a1x. And of course you can see the solution is decaying function, and that you can also see directly. That means for this kind of set, for when you have dy dx, you have only one solution. Okay? So that's what it says, that for a differential operator, minimum order of the operator should be 2 to have the equivalent vector space kind of thing. So here we can see only one root. So this is the only solution. Okay. So there is no question of basis. So this approach, what we did, y equals to for mx, which will be valid for any first order, second order, third order, fourth order, fifth order, nth order. So here there is no question to have Wronskian, only one solution. There is no question to have Wronskian here, only one solution. Okay. When we have, let's look at so now generalized approach. Generalized approach. I will pick up y double prime a1y plus a2y equals to 0. And from here, if you put y equals to e to the power mx solution, you get n square plus a1m plus a2 equals to 0. And the two roots are a1 and m. And if m1 not equals to m2, the solutions are phi 1x, c1, sorry, e to the power m1x and phi 2x e to the power m2x. Now the thing is that if there are two solutions, we can always combine them. First thing is the operator linear operator? We have learned that if n is a linear operator, we can write alpha a mu plus beta n b. Is the operator linear operator? Let's check it out. What's the operator? A equals to d2 by dx square plus a1, sorry, a1 d dx plus a2. And the linear operator. No question. The linear operator. You can try it out. So for the linear operator, so one approach is the operator is linear. Phi 1 satisfies the solution. Phi 2 satisfies the solution. And we can write the combined solution is alpha phi 1x. So you can write L alpha phi 1x plus beta phi 2x equals to alpha L phi 1x plus beta L phi 2x. Now L phi 1x satisfies 0. L phi 2x satisfies 0. If you put phi 1, L phi 1 equal to 0, L phi 2 equal to satisfy is 0. So that means L of alpha phi 1x plus beta phi 2x has to be 0 from here. That means this is the generalized solution. Right? So far everything is okay. I got two solutions. I am saying that generalized solution for linear operator, everything is fine. The question remains unanswered, whether they are independent. I have not answered it. I have said both of them satisfy the solution. Since the operator is linear, I combine them. I showed that they are 0. That's okay, right? Are they really independent? And we have to answer by Wronskian approach. Okay, what is my Wronskian? If m1 not equals to m2 by Wronskian, which is phi 1, phi 2, phi 1 prime, phi 2 prime, which is, so we can write directly phi 1, phi 2 prime minus phi 2, phi 1 prime. Okay, and my Wronskian for this case, it is will be what? To give me the answer. You have the solution, e to the power m1x, e to the power m2x. Phi 1 prime is m1 e to the power m1x, phi 2 prime is m2 e to the power m2x. What is my Wronskian? m2 minus m1. Excellent, thank you. So now, if this has to be non-zero, m2 is not equals to m1. If m2 is not equals to m1, this is non-zero, and that's what we have. So for two distinct, they are the linear independent solutions based on the non-zero Wronskian. Based on non-zero Wronskian, right? Based on non-zero Wronskian. So that's how you can see how the application of Wronskian. So whatever extra condition you got for the functional space, for the linear independence of basis, that is having direct application for for the solution. Now, interestingly, what will actually happen? Second case, if m1 equals to m2, what will happen? We have a differential equation, say dy by dx square plus 2 dy dx plus y equals to 0. In that case, the solution is m equals to minus 1, right? So, what will be my solution? So, this kind of things we have done earlier by dy dx equals to ay, that kind of part, right? We have done already the vector algebraic equation, differential algebraic equation. But here, this is another approach to look into. If m1 equals to m2 equals to m, if m1 equals to m2 equals to m, what is my solution? My final solution is phi x equals to c1 plus c2x e to the power mx. Why? You can say some we have done it. dy dx equals to ay. But you will see here by Wronskian. Another approach you can see. One problem you can tackle different approaches. So what is my phi 1? Which is e to the power mx. Solution basis phi 2x. What is solution basis? X. What is my Wronskian? Which is phi 1, phi 2 prime minus phi 2, phi 1 prime. And what is my Wronskian here? Calculate and tell me the Wronskian. Calculate and tell me the Wronskian. Calculate and tell me the Wronskian. How much is Wronskian? E to the power? Excellent. 2mx. It cannot be 0. It cannot be 0, right? So now you can see that this selection was appropriate. We have done the selection, but you can see that the selections are appropriate. They are independent solutions, and Wronskian tells us they are dependent, right? So this phi 1, phi 2 are the independent solution, and Wronskian says is non-zero. So that makes the solution basis. Next is if they are having complex conjugate. If they are having a complex conjugate, so that doesn't matter, because if they are complex conjugate, they belong to m1 not equals to m2. Same thing we can actually apply, and we can show that for the third case when you have the cos function or sine function, the cos hyperbolic sine hyperbolic function, they belong to the first category, and with that we can actually have we can prove how the Wronskian. So basically what we have done is, we have seen there are multiple solutions, and if the operator is linear operator, we can combine them and you can say they are the solutions. But the thing is that whether they are independent or not, that cannot justify. So to see the independent solution, we have to see the Wronskian, and all the cases we have seen the Wronskian is non-zero, and therefore the solution what we have actually got independent solutions, the solutions that they are independent solutions. Now more on the Wronskian. If I ask what Wronskian satisfies, it asks this Wronskian, does it satisfy the same differential equation? I am asking a question. The Wronskian you got, which is phi 1, phi 2 prime minus phi 2, phi 1 prime. Is the Wronskian? Is the Wronskian number? Wronskian is some solution, a number. What is this Wronskian? T to the power 2mx. It's some function of x. So Wronskian is some function of x. Here Wronskian is also found some function of x. Y is also function of x. If this function of x satisfies the differential equation. Understood? Wronskian is function of x, right? The determinant is a function of x. Y is also function of x. If y satisfies the differential equation, Wronskian will satisfy the differential equation. What Wronskian will satisfy? What differential equation? So that means if you know the differential equation what Wronskian satisfies, you can directly calculate Wronskian without having the solution. the Wronskian satisfy? Any idea? Yes. Will that you can see that Wronskian is function of x. Here also, for the m is m1 not equals to m2. Wronskian is also function of x. Is this fx satisfying this differential equation? Or if not, what differential equation will satisfy? If not, what differential equation will satisfy? Any idea? So next class we will show that Wronskian is satisfied exactly one or less differential equation. Okay, that will prove next class that Wronskian will satisfy first order differential equation. If your differential equation is third order, Wronskian will satisfy second order differential equation. If your differential equation is fourth order, Wronskian will satisfy third order differential equation. So next class we are going to prove that part and we will proceed further. Thanks for attention.